Hi, Anna. I made this cool thing with Dad at the library. We designed it on the computer, and then I printed it out. Here, look at it. But see, it goes out from the LED up to 1.5 centimeters, which is the 1.5 inches, not centimeters, of the star, which is the width of the star, and it will grow in that same kind of triangle out to the wall. So this is the biggest it goes, and then here it starts here, but then it has to go a thinner triangle to still get to the same amount because it's longer, and so it makes a smaller shape on the wall. Let's measure. Okay, right here I have a diagram of the shadow tube, and this part right here is the base of the shadow tube, and this LED there's also an LED in here. Then there's the cap, and there's also the cap, and it shows that when the light comes from the LED, it will go up to the star shape, and then it'll keep going up until it hits the wall in a triangular shape. And if it is all the way closed like this, all the way closed, and it's 6 inches away from the wall, then we know that it will that the length of the star on the wall will be 3.43 inches. Okay, and I also have this one, which shows that if it is 1 inch away, so instead of like this, like that, then it will show, if we're doing the same amount of distance from the wall, that the LED comes, and it has to have a skinnier triangle to be able to still have the same width at the end because it's a longer tube. And then it keeps going in a skinnier triangle. So it will end up as 2.48 instead of 43, yeah. Okay, here I did calculations that I'm calling this L wall, the length to the wall, and this D wall, the distance to the wall. The length of the star on the wall, sorry. And over here I'm calling this the L cut, the length of the cut, the star cut. And here, the D tube, which is how long the length is of the tube. And so here I have, I did L wall by over D wall, and that equals 2.48 over 6, and that equals 0.413. And then I did the same thing over here, L cut over D tube, 1.50 over 3.63, and that also is 4.13. So we could use that math to, on this hypothesis I made, to figure out what the length of the star on the wall is going to be, because we can do that. We know that the L over the wall, L wall over D wall is equal to L cut over D tube. And so we used algebra here, and we did L wall over D wall, and then we canceled out the D wall, and then we did L cut over D tube times D wall, and then that way we know that L wall is equal to L cut over D tube times D wall. And so we could just figure out what this number is equal to because we know all of these numbers. And then we would know what the shape on the wall would be. And that way we could figure out what it would be before we even did the experiment. going to figure out what L wall is now. So we're going to do L wall equals, we know what the L cut over D tube is, and so it's right here on this diagram. We figured it out. And so I'm going to write underneath this 0.413 and then but then we still have to do the times D wall. And so we're going to measure how long this is right from the bottom of the tube. Oopsies, wrong side. All the way to the wall. And right here we have 25.3. And then that equals 10.4489, which I think we'll just round to 10.45. Okay, and then there we have what we think it's going to be. So now we're going to turn off the lights and turn on the shadow tube. And then we'll measure what that is. And it is 10.2. So we are very, very close. It is really nice to have you watching this video. Thank you for coming.